You had to do everything. You just had to give the properties for the evens. So, in your textbook, if you are looking at your textbook, this is section 2.1 and 2.2. And this is review from last year of solving equations, okay? So if you need to look someplace and you're like, I don't get this, you can go to your textbook, and I don't think we'll get the online ones, but you have your devices now. You can get your online textbook at any point in time. I have that on the daily planner. All right, so usually what I will do is right up here as you come in the door, I will have a spot where you can put your questions. And today, I just need some numbers that you're thinking of. Which ones do I need to take a look at? Any up there? Yeah. 30. 30. Okay. Any other ones besides 30? Yep. 33. So in 30, I have 1/10 times h. I want a 1 in front of h. So my goal is to get 1h. I have 1/10 times h. What can I multiply 1/10 times to get 1? I'm going to multiply it by its, Sanjay, what? 10 over 1, it's reciprocal, right? So over here I had negative 22 over 5, and I'm taking that times 10 over 1. Now for me, I like simplifying my fractions right away. If I don't have to use my calculator, I love it. So 5 goes into 10 twice, and negative 22 times 2 gives me a negative 44. Now, it did say up above to solve and check. So what do I write for my property over here? Well, what did I do on both sides? This would be the multiplication property of equality. If I am doing the check, oh, I forgot to do the check. So make sure you know how to do it, and make sure you write this down, and then you're going to go back in your homework and do the check. To do the check means to do what? If I was specifically asking you, how do I show what the check is? Emmy, what would I have to do? My original problem, I'm going to do what with my original problem, Elizabeth? This original problem right here. What do I want to do with the check and that original problem? I am going to, well, kind of work backwards, but more specifically, I'm going to do what, Abby? I'm going to plug in what I got for my answer. So to do the check, and I will be asking you at different times to do the check because our problems are going to get like not as easy as they were last year. I'm putting in 1/10, and I'm putting in negative 44. And I'm trying to see, question mark, does it equal negative 22 divided by 5? And if I look at this and I have 44 over 1, right, because I can write that as a fraction, 10 goes in here, 5 goes in here, or 2 goes in here 5 times, and 2 goes in here 22 times, and I definitely get negative 22 over 5. Could I have put this in my calculator and put both sides in my calculator and checked it that way? That would also work, right? So, if you did not show the checks, especially, I would say from like 27 through the end, you want to make sure you do that, okay? And some of you yesterday, I'm not sure why, these 4s were up here for a couple of days. You turned your paper in without writing those down. You didn't get all the points. You were asked to give me as many ways, and I said they're up here, and you can copy them, and you can come up with more. So some of you lost points yesterday on that activity because you didn't finish it. And some of you didn't finish that graph activity, like that question G on the back page, and you just didn't finish. You don't get all the points then, right? If you're not finishing the assignment, you're not getting all the points. I just want to make sure when things are up here, and like this was up here since the first day, and people added to it, but you had nothing on your paper except for like maybe 3 of them, that's taking the time and getting it done. You could have used anyone to help you with that. You could have checked with your parents, siblings, you could have worked with buddies, I don't care. But I looked at that, so that was part of the assignment yesterday. So when we read this problem, Hayden, you want to read this first?
Jeremy rode several miles to earn money for camp. After he paid $17 for gas, he had $75 left over to pay per camp. Write and solve an equation to find how much money Jeremy earned mowing lawns.
All right, so what do we know? He was paid 17, he had 75 left over. We might be thinking of it as D, right? So, or whatever variable you like. Okay, we're going to figure out how much money he earned mowing lawns. M for money, whatever variable you want to use. He had to pay $17 out for gas, and he was left with 75. Don't make it harder than you have to, right? So as we look at this equation, it then says, write and solve the equation. So one of our standards is you have to write it, okay? Minus subtract 17 because you paid 17 for gas, and then you're going to solve it. Did anyone have a different equation besides this one? What did you have, Owen?
75 plus 17 equals 9.
M equals 75 minus 17. I take that equation. Plus, excuse me. I would take that equation.
That's 17, 5,
17, right? Not 50. 75 plus 17. I take that equation, right? That's an equation. And then you're still going to solve it, right? So this is the equation, right? Using the information in our problem. So one of our standards when you are writing these is that you need to be able to solve and create equations and then solve them, right? So this is a creating equation. Will both of these forms work? Yes. Do you want to put this answer, which was how much? 92. Do you want to just write M equals 92? That would be the solution, right? And then you're going to answer the question like with a sentence. But if you only put this down and you don't show me, you know, if you added or that you did this as a subtraction equation, I have to take off points for that, right? Because you're just kind of giving me the solution. You're doing it in your head. That's fine. I just need that, okay? So that page in your workbook, just have that open so as I come by, I can see that. Number 32, you should have two properties. I need it up here so I can see it because I can't see that. Number 32, you should have two properties, right? The first one was either addition or subtraction as you looked at it, and then the second one was probably a division, okay? All right, turn back to the front to your notes. This is a really short video that I found on where matrices are used, and I think it's pretty decent. So I want you to just kind of read through that vocabulary part, and as you're looking at that, and just kind of read through what they're talking about there. And then I'm going to put this video on.
Hello, this is Albert.
And this is Michelle. And we're going to talk about the applications of matrices in real life.
What is a matrix?
What is a matrix?
Aha! The matrix is a 1989 and known for popularizing the word.
No, stop! That's the matrix movie.
That's the matrix
I
movie.
meant the mathematics terms of matrix and matrix.
And matrix
is actually the Latin word for shape. It can also mean something to restore or reduce. This shows an M-type matrix of M and Now, what are the applications of mathematics in real life?
There are many uses of matrix. Architects use them to make architecture, which have great architecture.
But also can serve its purpose such as supporting historical structure. On the other side, matrices play a great role in what they are used for. And also scientists use it for
In encryption, users scramble the encrypted so that the encrypted is not accessible unless they have
Now this key contains a random sequence that is used by matrix.
See how awesome it is?
Furthermore, they use it to alter the object in which they edit in a 3D space such as a monitor.
The way they actually convert it to 2D is actually a similar method on how we type.
In here, it shows that three lines is actually becoming two matrices.
Some matrices are even dense to organize complicated groups.
The contrast-dancing is a complicated dance, but with the help of matrix, it becomes easy.
The last part of application of matrix is the economics and business.
We use matrices in the world to add tables data at the same time, but maybe in a different one.
Examples are the cost of opening and exiting.
Nowadays, with the expanding industry in the 21st century, matrix are getting more and more
So,
useful.
what do you think matrices can do to organize this video?
Thank you for your attention. I hope you enjoyed our video.
So, it seems that there are quite a few places where matrices are going to be used in your life. And the key thing that I want you to think about is this. I want you to write this up here. It's a way to express a linear map between finite dimensions. Now, if you're reading this, you're going, I don't know what she's talking about. Finite. You might look that word up, right? Finite dimensional, and they usually call them vectors. So if you're next year in geometry, you do vector addition, vector multiplication. Anyone remember, is it, who's the movie, with the little minions, what's his name? Drew, right? Then the vector, isn't the guy his enemy in the first movie? And isn't it something vector? I can't remember, it's been a long time.
His name's just Vector.
It's what?
His name's just Vector.
His name is vector. And so this is, this is kind of a play on mathematical stuff. So with finite dimension in vector space, okay? So you actually will be working with vectors in the next year or so, right? They're kind of something really important in mathematics and in geometry to work with. So matrix, matrices, okay? So matrix, the prose matrices is a rectangular arrangement simply of numbers inside a bracket. The numbers are lined up in rows and in columns, and they are used to organize our data to make calculations easier. So if you would continue reading that, correct, where it says matrices are identified.
Matrices are identified by the number of rows and the number of columns. The matrix below is a 2 by 3 matrix because it has 2 rows and 3 columns. They are always identified as rows x columns. Each number inside a matrix is called an element. Elements can be integer fractions, decimals, variables, etc. Matrices are equal if they have the same size row times column, and the corresponding elements are the same.
So, anyone watch Netflix? So, Netflix, they store all their information of what you watch in a matrix so that they know when you get back on. Do you ever have them come up and after you've watched a couple of things where they recommend you to watch something else? They've stored your information. They use, what they do is they store your information and it's stored digitally in a matrix, okay? So they store your information in matrices, and then when you come back, they recommend and they say, hey, you know what? You liked this show? Why don't you try this one, right? That's how they use it in business, right? If you are computer graphics, that's how they change from something 3-dimensional to 2-dimensional, right? On your screen, it has to be 2D, right? It might look 3D, but they use it that way. In architecture, programming, and scientists are going to use this, so there's many different places that you're going to see matrices. So, as you read this, at the top, if we are reading, let's see, Josie, you want to read for us, please? Jeff, Tina, Eric?
Jeff, Tina, and Eric run a landscaping business. They charge $12 per hour. Below are several sticky notes listing how many hours each person worked. Represent this data with a matrix to organize it better so that they can figure out what to build.
I want you to focus on Saturday. That's going to be key. So, if we're looking at Saturdays only, for Jeff, Ogawa, we put what? How many hours? 5. And Baker's? 2. How about Tina? Saturday. Are we going 2 and 1? Oh, we gotta go on Saturday, right? Okay, we're going Saturday, right? So Saturday. So what are we using on Saturday if we are looking, right? We should have 2 and what? She had 2 hours, and we're talking about Tina, right? 2 hours. Baker?
2 hours.
Wait, we're going Saturday only. This is Sunday, right? Tina's Sunday worked here. Smith's Sunday. Jeff's Sunday. This Sunday. So here, we're going to have 2 and Baker's 0. How about Eric? 3, right? Going here. 3 hours. Saturday. How many at Baker's? 0. So when I look at the matrix, this is what I want you to make. If we are looking at this matrix of this, we want to put these brackets around it. And you're going to write it like this. So please do that right now. So from that table of information, we're now writing it in our matrix form. So please copy that with those brackets. They're 2 big brackets. All right. So it says to add or subtract 2 matrices, you add or subtract the numbers in the matching position of the matrix. It must have the same size in order to do addition. The same number of rows and columns. The solution will be a matrix that is the same size as the original. If you are asked to add or subtract matrices, as you are looking at that, they are not the same size. You're going to say that it is undefined. So, notice what they did. They took 3 plus 4 and got the 7. They took the 8 plus 0, got 8. 4 plus 1. So, right now, I would like you to look at this one, and we're going to do matrix addition. If we are doing that, first off, we are looking at the size of our matrix, okay? And it is always, when we look at our matrices, as we are looking at them, we are always thinking of our matrix as row by column, okay? So, row by column. This would be a 2 by 3 matrix. Rows go across. Columns are like when they're out in front of your house or big buildings. Columns go up and down, right? So rows go across, columns go up and down. So we're going to start doing our addition. 3 plus negative 1 gives us 2. Negative 5 plus 4, second position going across, negative 1. 4 plus 2, 6. Please do that bottom row if you haven't. As I'm looking at that bottom row, Dylan, what do you have for the first one?
-6.
-6. And if I keep going with that one, what am I going to have? Is it Alania or do you go by Lady? Okay. 2. And Elena, then. Okay? Please do this one right now. Any questions as you're looking at this one? Yeah.
So for the x minus y.
X minus y. How do we write it?
X minus y.
X minus y. That's x minus y, right? This is 1/2, 3 1/2. Okay? negative 2. Oh, subtraction. What do you have to do with subtraction? What's this first one? Negative 4 or 0? 0, right? So when you're thinking of subtraction, right, sometimes it's easier to think of adding, and maybe then we take the opposite. This one, opposite, right? So we got 0, x minus y, and what's our last one if I am looking at that last one, Whitney? What'd you end up with? Negative what? Negative 1. Did we write negative 1 instead of negative 2 over 2? Yes. Would I take negative 2 over 2? I would. Okay. All right, multiplication. Next one down. So scalar multiplication is a real number factor by which you can multiply a matrix. This is called scalar multiplication, and you do this. To do this, you multiply each element by what? It's kind of like distributive property. That's the easiest way to describe it. Distributive property, right? So you're taking 2 times everything on the inside. Some people like to write that down. If you need a calculator, but you shouldn't. 3 times 4 gives us 12. 3 times 1 1/2. If you're looking at that. 3 times 1 gives us 3, right? And then half of 3 is how much? 1.5. So this should be a negative 4.5. Right? Okay? Continue and finish that multiplication. Right? You have to keep the brackets. That's our way of organizing it. If you don't put the brackets, I have to mark it wrong. If you just put 12 negative 4.5, and then the bottom row, if I was looking at that, Caitlin, what'd you have? Do that next one. Oh, you got variables. What happens when you multiply your variables? What is negative 2x times 2x? How many x's do you end up having? 4x to the second. It would be negative. Usually when we have more than one variable, we keep it alphabetic. Yes? So if I was multiplying this out, I have negative 2x times 2x. This is x to the first, and this is x to the first, agree? So I have negative 4, and then I have x times x, but we don't like writing x times x, so how many x's? X squared, good question. So the next one, if I'm writing that next one, I am going to have like a what? Yep. As I go to that following one, if I'm looking at that one, I should have, sorry. Close. Why not just negative xy? How many x's did you multiply? Right, you did negative 2x times 1/2 x and y. The negative 2, I agree, that's going to give us a negative 1. X to the second y. Okay? And then our last one is 0. Okay? So, you're just going to be doing addition and multiplication in your homework. Okay? Addition and multiplication in your homework. Okay? Tomorrow we get into the yuckier part of multiplication, and it's kind of weird, and it's not just, and that's where they're talking about switching from 3-dimensional to 2-dimensional. It's when you multiply matrices. And then, I mean, look at it. There's tons of YouTube videos out there besides what I'm going to do. Khan Academy has some decent ones too. If you're just not getting it, you guys have so many more resources at your fingertips, right? Because a lot of you have smartphones, but even if you don't, you have a computer at home or you have something and you can go and do a YouTube search or a Google search and find something out. So you are doing this, okay, through number 24. So if you turn to the back, you have these 2 pages, okay? Questions. I'm going to get you started, and what I'm going to have you do is by row, you're going to come back, and I'm going to be checking out. So, sometimes what I do for these homework quizzes, sometimes I'll let you work with someone, other times I'll not. I don't know if someone in here left a calculator, if there was one left, and I don't know if it's from this period or for a different period. So you're going to start your homework, and right now we're just going to take this short little, when you turn in papers like these homework quizzes in the back, you're going to see a section that says door. These are my people that are sitting by the door. All your papers will go in that pile, okay? If you turn to the back, all of you guys are my middle section. So you're going to put your papers back there in the middle, and then over here, you guys are going to be the window people. So depending on if you switch seats during the year, right,